Welcome to JD's Prep. In order to figure out which one of these four statements is true, we need to be familiar with even and odd functions. So as a little reminder, a function is even if f of negative x is the same thing as f of x. Graphically, or visually, that means it's going to have some symmetry across the y-axis. As an example, let's say we had y equals x squared, or f of x equals x squared. That has symmetry across the y-axis. In other words, it has if you were to do a reflection across the y-axis, it would look the same. A function is odd if f of negative x is the same thing as negative f of x. Visually or graphically, that means it's going to have symmetry across the origin. As an example, let's say we had, let's just say we just had x cubed. So f of x equals x cubed is an odd function because if you were to both reflect this across the x and y axis, or if you rotated it 180 degrees about the origin, you would have symmetry. Now, for f of x being this equal to cos of x, we roughly have an equation that looks like this, or a graph that looks like this, with a maximum at 1, minimum at -1. Now, if we look at statement number 1, it says that 2f of x and f of 2x are both even functions. So let's check that out. 2fx is the same thing as 2 cos of x, and f of 2x would be the same thing as cos of 2x. If we were to graph those, first off, 2 cos x is going to look the same as cos of x, except the amplitude is going to be doubled. That also means our min and max will now be at +2 and -2. So it's going to look something like this. And as we can see here, this 2 cos x definitely has symmetry across the y-axis. In other words, if we were to reflect that across the y-axis, it would look the same. So yes, that actually is an even function. Now, what would cos of 2x look like? Well, that's actually going to be a horizontal stretch by a factor of 1/2. Okay, so it will have that original maximum of 1 and a minimum of -1. However, it's going to be a bit more rapid, kind of like this. Of course, this isn't as accurate as it could be, but the important thing here is to ask ourselves, does this have that same symmetry across the y-axis? Yes, it definitely does. So no need to go any further. We've proven that both 2f of x and f of 2x are both even functions. So statement number 1 is definitely true. All right, that's it for this video, and thanks for using JD's Prep.